Okay, I'll start with, I guess, the whole training. I guess more formally I'll start right now. So I did provide, there's two of these, so just a basic walkthrough of like the stuff I'll be loosely covering. It's mostly here as a point of reference for me that I don't forget something, just so that you have a rough idea of what we're going over. So to contact us, basically contact us section. So basically, like if you are having issues, you can always contact us. Angstrom has like a really, really good like customer service work. Like we will honor our machines and materials and help you guys as much as we can, because we synergistically work with you guys, because the more you use this machine, the more you enjoy it, the more you get value out of it, the more we can also learn about how we can better make the machines. So it's like we love working with our customers for that sort of stuff. Typically speaking, if it's like anything maybe machine specific, or you are struggling, like we were discussing with a process or a new material or something like that, you can reach out to me. I have business cards I'll give you guys at the end. And you can just send me an email. If you notice that you're getting an auto reply, maybe I'm out installing another tool somewhere, it's more urgent. You can also reach out to our service team as well. Also for larger items like our compressor is dead, we don't know what's going on, you can reach out to our service team as well, but you can also CC me. I like to know because I might be able to have a better idea of where to start, because I installed the tool, I worked on the tool to get them all up and running and test functionality, so I might know some of the little quirks if there's something that was standing out in the startup of it. So that being said, yeah, don't be scared to reach out to us if you need a hand. And yeah, so we're going to start with the system utilities, so we're probably going to start moving around a little bit here. Basically, the majority of what you care about is over here. And this would be the same on both tools, more or less. Only difference is there'll be more gases and things like that on the other one. So you'll see here you have your pneumatic disconnect. This is for your air. This is your nitrogen that's being fed in. You can see here purge, vent, nitrogen. It's all labeled with roughly what pressures you need and things like that. There's an EBeam ground. This is where your water comes in and out of. And your pneumatic gas and things like that. And your cryo exhaust. This just goes down to your rough pumps down there. And the rough pumps also then go to the building exhaust at that point. Pretty straightforward for that. There's sort of requirements for like what is expected of those, but I mean for the majority for this tool, there's not much other than the vent gas. It's just we recommend it to be nitrogen. You can also have the argon instead. I know that there's different hookups here available to you depending on what you're working with. That might be advantageous, but since you're going to be exposing to atmosphere shortly thereafter, nitrogen's usually fine. Yeah. So on the other tool, we can cover that. I mean, for process gases, as you know, you probably want something like 5N, so like 5.9, so like 99.999 kind of thing, typically speaking. Water, yeah, like we're pretty flexible on this. Tap water, reverse osmosis, or distilled, or you can also do mixtures of tap and deionized and things like that. We just don't recommend straight deionized, because anything that we run it to, say like with the sputter machines, the sputter heads are made of copper, and it will eventually leach the copper out of it over time. It's just one of those small things that we know that service-wise we've encountered, and it's not worthwhile for you, me, and the headaches it's going to provide. So just having it set up initially is probably best. On the other side of the tool, which we'll come around to, there is also the electrical disconnect. Ignoring some of these panels, sorry. This is also our electrical disconnect. This also has our plugs for our compressor and rough pump. So this disconnect is always safe to turn, to be able to turn it off. And when off, this red tag, you can see it has some movement to it. You can pop it out, and you can lock it out if you ever are doing electrical work. So okay, keeps you extra safe. Not stuff I hope you have to ever encounter, but of course, if you're just moving the system or something larger where it's going to involve that. Otherwise, this is just the main power. That's where that comes in. pretty straightforward. The requirements for the electrical are just, again, stickered onto the tool there. Shouldn't need to be something you need to be routinely working with. And yeah.
Is there any reason for Ethernet?
Oh, this?
Yeah.
So this is actually quite useful. So this is for if you guys need support, then you can either hop us onto your Wi-Fi or like this, and we can team viewer into the system.
Oh.
And so we can remote access it. So if you're struggling with a process, we can watch it live with you. We can work through it with you. We can hop on like a Teams call or something and just sort of help you guys set that up. If we didn't have time, like if we had some major utilities issue coming into this, sometimes some of the training's done that way, just so it's not an uncommon thing. Happy to do it as well.
That's cool.
Yeah, it can also be good for if you're having an issue and you're like, I think it's recipe related, I can hop in and I can go look at your recipe in 2 seconds basically and just immediately go, oh, that needs to be there, you know?
Okay.
Yeah. Cool. Yeah. So yeah, you can either hardline it or you can put us on the Wi-Fi, but I know Wi-Fi gets a little like questionable with tools at some facilities, so yeah, that's why we offer both. Okay, so in behind this panel is a little tiny industrial PC. It's what sort of interfaces to the PLC that operates this tool. PLC is just on this swing panel. We are probably likely moving these compressors from my understanding, so it might be a little hard to see right now. Maybe I can get a better showcasing of this for you tomorrow, but this swing panel kind of comes out, and your PLC is up here. You'll have a variety of like fuses and things like that. The reason why I'm pointing these out to you is sometimes if something's not working as intended, and we can't quite see a reason for it via the software, we might tell you to go back here and go look and see, hey, are any of the fuses blown? There's more fuses further down here that are in white, and some on the ground as well. And there's also a circuit breaker that would be for the transformer for those resistive posts. Otherwise, on this back side, or we're going to go back to the other side, sorry. So on the other side of where I pointed out that you had all your inputs come in from your building, your gases, etc., we also have feedback from, there are flow meters in here, which may be hard to capture. This one right here, for example. But you can see we have 1.8 GPM going to the EBeam right now. These are also used for interlocks, so that way if the flow of water is too little, you don't have overheating issues and have a bad time, basically.
And have a bad time.
And we also have our pneumatics come in here, and on this side, which I may step out of the way for you, but right here, this white block facing in this way, there is a readout of what pressure it's currently getting. That's how we knew air pressure is wrong. Software also was spitting it out, of course, but that's, so if you're ever seeing something like air pressure's not okay, you would come check here and say, is it actually not okay, or is this reading wrong versus what I'm getting on the house level? And also
readout at
so I believe it's at 82 right now, and we aim for above 60 psi.
Okay.
And you'll see here, yeah, we also have it here, and they also have a gauge on there.
That's awesome. That's awesome.
All right, and then I'm also going to cover another safety feature here, which is this big red button down here that everyone loves. That is our e-stop. So if you are ever noticing an issue in your process and you would like to stop it immediately, you can, of course, go to the main power and disconnect it. That will be shut down the entire tool, which would then lose your pump down a bit and things like that. Whereas just hitting the e-stop, what it does is it acts as like it cuts your main control relay. So it'll actually like kill all the power, all the stuff inside the system basically, but still keep the computer running. So you're still able to interface with it.
Okay.
So that way you can still like, you're basically very quickly stopping a process. Like let's say our software is glitching out, you're hitting stop, it's not stopping. That's your just immediate kill switch.
If you hit that, does that keep it off until you, or does it just like?
So it has like a twist. Okay, so you have to perform the twist, like you'll twist it out basically to pop it out.
Okay.
And that will drop, or then put it back into a, you
can turn it back
on. It'll turn everything back on, but it won't like go to where it last was because you've killed power to your source and stuff. It's not going to immediately shoot all that power and continue the recipe like nothing happened.
Yeah.
This now goes into a faulted state basically, and it'll say, yeah, something is clearly wrong. We've dropped like a ready state, so like basically all your sources are stopped and all that good stuff. Then you would probably just pump down again after that, and then you're what I like to think of it like neutral, like keeping your car in neutral. It's like there's a neutral state for this tool, and typically speaking, it's pump down. Like you just keep it pumping.
It shuts everything down except for the computer, like including all the pumps.
So it'll stop the pumps briefly, yeah. But by going and hitting pump down, it'll just re-engage the pumps so long as you do it within a reasonable period of time. The only reason why I say that is because these are cryo pumps, and if they sit for too long without compressors running, they will of course heat up.
I'm just curious what
level
what I would need to hit that for specifically, like what I immediately want to shut off.
Yeah.
So
if you're just ever in a spot where you want to stop a process that you feel like, or like for some reason the software's not letting you, or you're struggling to, or you're just not sure at all, like let's say it's very sensitive. Like let's say you had, like you noticed it was drilling into the E-beam hearth because you forgot there was no material in that pocket. If you were not paying attention, for example, then you would quickly hit that, right? You wouldn't feel like, oh, stop. It's like, no, I can do this off. But reasonably speaking, that shouldn't be possible. But just in case you
okay. So
there's a variety of interlocks and safeties that are coming with the system that I test for. So we're in good shape. So yeah, I'd say like as far as like the main hookups, that's them. For the I cover some of the more basic ones for the system startup, which is that if you were to have this tool entirely off, turn it on, Aries should automatically, like Windows will open up, log in, Aries should start to load. So it'll look a little something like I can actually just force close Aries. Yeah, so you saw I hit this Aries startup button, and then you'll see in this bottom corner we have a green A, that's our engine for the Angstrom software of Aries, and you'll see it's just loading up now. There's a few other scenarios, of course. There's red, which is contact us. Something's wrong. It's broken for whatever reason.
Sometimes if that is red?
Yeah. The color of it is red, then you'd know that something's wrong. If it's blue, it could be something's wrong in terms of like you may want to try closing the engine and then restarting up again. And if not, just reach out to us. Orange means it's connected to the PLC, so when it's first starting up the computer, you might see it orange at first, and the orange just means that it's like still just making those connections. And green is good. Yeah, green is good. Green is good. I'll then start going over the majority of the components on the external of the tool here. So maybe we'll start with the cryo since we sort of already went over it. Right here is your gate valve. This is just really dummy, open and close to your system. This is, of course, your cryo chamber with the array in it. This is the cryo pressure gauge. This sort of just monitors, like it basically is always getting pulled on by vacuum or when you go to do your regenerations. So that way it'll like keep it clean and give you feedback for that. Just it does a rate of rise to ensure that it's not leaking back too much during that regeneration. Otherwise, that's still either too many contaminants outgassing or that there might be a leak along these lines potentially, right? But again, we've regenerated, we're running. I have doubts that for the next little while that's not going to be the case. This is the cold head. This cable here is for the cold head power supply. It comes from the compressor. It's what powers this to be able to actually do that actuation. Right here you have your helium lines. They're labeled supply and return. They go to your compressor. The compressor itself is a little more involved, and I'll cover it when we go around the other side. Here is your pressure gauge for the chamber. This one, it has dual functionality in that it is both a cold cathode and a Pirani gauge. So that way you can capture the low end really good, like the really, really low end high vacuum with the cold cathode. And then the Pirani gauge catches the like near atmosphere level as well. The Millitor range is where it sort of struggles. On the other tool, there will be an additional gauge that uses a capacitance diaphragm to better like monitor the pressure in that range. Other than that, this is like the rough valve, and this is your vent valve. They're both pneumatically actuated. So in the past, people have tried to run these tools off of compressed air tanks. That's problematic, of course, because they're always using it just to open and close valves constantly. It's used for actuating your shutters, open and close, which is done by these up here, which are pretty straightforward. You can see there's just two dials. They're very sensitive little dials, though, that will affect your open and closing speed, so I would suggest leaving them. And there's just two positions when you pop this little cap off. There's a little plastic cap. When you pop that off, there'll just be two basically screws in there, and then it's just got a little hammer that runs between them. That one is open, one is closed. There's a sensor on them to sort of just make sure that that's the case, typically speaking. And yeah. So as far as this side of the tool, I think that's all of them. Oh, other than our beacon, you can guess what green is. It'll probably save you some time when you're outside of here. So see, blinking green is your process finished and it's good. If green light is on solid, it's running your process and it's still in a good state. Okay. If it's blue, that means it's above base pressure, which is a set value in here. It's just sort of a making sure that you're pumped down value. But on the sputter, that might be normal for when it's in a process because you're running in the military range. So don't be surprised by that. And we all know what red means. Yeah. But that can save you some time if you're ever outside and you're just running by, you going, my process is still okay. I know that saved me many a times. We also have on this front panel, this is going to be the feed out of your EBeam controller. This is your sweep controller, and this is your power supply, and also your beam control. Basically, this one controls the power. This one is your power supply. This one controls your sweeps. I'll cover that a little when we get into the running of it, but yeah, basically this is your front panels to be able to interface with them. And so if you're ever having trouble, sometimes it's worth looking at the front panel for troubleshooting. It might tell us a little bit more. So we may ask you, you know, if you're having an issue, why does it still say high voltage inhibitor and stuff like that. Some small things. This is a piece of welder's glass on here on this front. And this is meant just for if you're running an EBeam with, say, something like silicon dioxide. It's very bright. It can be almost blinding. So that's, of course, why it's there. But once you pull that back, you can see into the chamber. It's not bright right now because we're not running anything. But it does have sort of this little flap here to be able to, it has a little mirror on this surface here. So when you go to open it, you can actually just look in and you can see down at your sources when they're running. Make sure your pattern's moving appropriately, things like that. Lastly, I guess it's just the compressor. I'll let you guys come around to this side and you from the back side because I can show you exactly what it's going to look or sound like. But basically, this is pressurized helium. For those of you familiar with how engines work, typically speaking, think of like an adiabatic expansion. That's what keeps your cryo cool, is that it's helium expanding, contracting, and then that's also what's driving it at the same time, is the pressurized helium. So as it goes and does that expansion, it cools off and then contracts, etc. So you'll see here that it's got water lines going to and from it. If it has poor water flow, it may shut off from overheating. It's built-in safety circuit internally. There is also your pressure for your helium here. And you can see here, let me see if I can time this right, but should be at about 250. If you see it slowly creeping forward, it's just a matter of the fact that I stopped it on one side or the other, basically, of that push-pull. And basically, that when you want to do your checks for, you know, your helium levels, if you're not sure if you're having issues with the cryo, that's typically what you would do. There's just a little on-off switch on the front here, so that's all I'm doing, basically, because it's currently getting powered to be on. But yeah, that's what it'll look, sound like, etc. Yeah, and always reach out to us if you have any issues with that. One last thing I forgot to mention, you have your manifold here for your water. So if you are ever in a situation where, say, the EBeam had to be sent back to us, or you have to check, like there's one scenario where we wanted to check basically how the EBeam is being affected by the pressure of the water, basically. You can always just turn off the valves, they're all labeled appropriately, so you'll see things like comp water supply, compressor water supply, and it'll be something like that, EBeam water sup, EBeam water supply, you know, and then it might say source 1 or source 2 or resistive 1 or resistive 2 or something like that. And then there's 2 spare lines, I think, in the event of upgrades, or if something goes wrong with those lines, you can swap out to those. So I always provide them. Underneath here also, a little deeper into this tool, is there's quartz crystal monitor like connections there. There's little boxes. Sometimes you may have to just unplug and plug the USBs back in the event of troubleshooting. Nothing that I'm expecting, more just so you know where they are. What else? I think that's it. There's 2 transformers down there that are used for your resistive thermal evaporation sources. Otherwise, everything else is like the back of those front panel units are here, and we already went over the electricals that are sort of here and on the ground. So that's it for pretty much the outside of the tool. I'm going to vent it. We can take a look on the inside so you guys can see what you're what you're working with. And in the meantime, you can ask me maybe just as a very basic intro to the software. You would go to your system, your vacuum system page, and then there's a pump down, vent, and a regen.
Basically what he's been going over.
So we're just going to look to vent here, but you'll see here there's options that are grayed out. Now this is because they're currently just not available because we're at the operator level. So this is one of those things that if you guys are going to be building recipes and stuff like that, you're going to need to be at supervisor, which is what I was told. I'm going to hit vent, and it performs an automated sequence for venting the chamber. And it spells out what it is. So if the sources were still hot, like your resistives, it doesn't really have a thermal feedback for. It's typically more like the heater units inside the stages that are better monitored for that. So it'll open this vent. So it's opening the vent valve. It's closed the cryogate valve. You can look on this overrides page and see all the things that it's done. But it's exactly what you'd expect it to do. It's just all automated, so you don't have to think about it. Same goes for when you pump down. It sort of lists out what it does. Same idea with the regen. It'll go through these steps on a regeneration, so it makes maintenance way easier.
Wait, this does a regen?
Yeah, it'll automatically regenerate.
Oh my God.
Yeah, I've heard that many times. And then this one also, you can just tick this little box, which I always have ticked, which is to pump down the chamber when you're done as well. So it'll do the regeneration for you. I recommend you just do it on a Friday afternoon when you know no one's running anything.
Yeah.
And away typical things though, so you can see here the elapsed time, the estimated duration. My guess is you could probably pop that door open because we're almost at 6 minutes. Yep, just that latch. And that's your system. So also in that vein, you can see how long it takes to pump down. That depends on sort of what you set as your base pressure, about 40 something minutes. But that's probably for 2e to the minus 6 as a deposition pressure. Some basic safety things also just to cover them. You know, obviously there's respiratory hazard of if you just were depositing a lot of stuff, then you just crack the door wide open after venting. If it was flaking, then of course, you know, take appropriate precautions. Things like silicon dioxide is where I'm coming. There's things people do, I don't know. But obviously, if it's hot, you know, do a touch test just to be sure that it's not going to just melt your hands off or anything like that. Or if you're close and it feels warm, don't touch it. Give it some time to cool off. Once you're at atmosphere, things cool off relatively quickly. Things in a vacuum don't.
Yes.
Yeah. A maintenance guide inside our Aries help manual. It outlines a vast majority of this tool. So if you ever have exact questions, things like even recipe actions, what they exactly do, what each individual each individual inputted value is for, and what it's trying to do in that action. Just in case you find it, you're going to find a bunch of actions in here that probably don't exist on this tool or don't exist on this tool. And that's just because we do a wide variety of tools, so don't be like, oh, where's that one? I want it. It's probably just not needed for the tool. So this is our sources page. You can see here, there's a broad overview to show you them all. You can go one by one, and you can do things like disable them. So if you're getting a constant alarm from your EBeam for whatever reason, but you still want to be able to run your resistives, and you're still working out with us, what's wrong with my EBeam, you know? you can go through and disable all the EBeam ones, for example, and then you can just keep running your resistors without being hindered. So on the sources, though, you'll see here your resistors. You can run them via idle control. This is me just trying something out just to make sure I was getting feedback. And it was just circuit breaker wasn't on, so I fixed that. So enable idle control here. The idea is that I can manually run these two. Again, it will wait until it's at base pressure. It will not let me just do this at atmosphere or anything else. It's not, again, these are all sort of interlocked. CT10s are fun. Basically, though, yes. So you can run these manually, basically. If you're ever just wanting to check, one, you can check continuity across it to make sure that you will, like, run current through it.
Yeah.
If it's not going to do that, you're going to struggle. So that's something you can do at atmosphere before running. I've already checked those two, so I already knew. Otherwise, I would recommend, just quick multimeter, just continuity, bang, bang, get your beep, and you can go. Then you can see here there's a measured current. Then output is a function of sort of what the transformer can actually provide it for power. You'll start getting more comfortable with that concept as you work with recipes, I would say. So this is more of advanced user work, is running sources independently or manually like this. And reason people might want to do this is just to either evaporate out the last bit of material or things like that, or just see what it takes to get a response, because you still have your sensor page here, so you can actually watch it as well. So that being said, you'll notice you can't run your EBeam manually like that. It's because it's sort of a lack of control, and because the EBeam itself on this one, I believe, has a 6 kilovolt EBeam supply. So that's a lot of power. So then you might just go 2%, and then all of a sudden you're drilling and spraying stuff everywhere. It's very easy to do. That's why we tend to not really allow it to be like manually controlled. And it might have to do with the way it interfaces. So that overall, that's why. But we can build very light recipes that will let you do live updating in your recipe. So you can just work with it that way instead. It's basically the same as working with this. So. Now, again, the sensor page. So you can see here what frequency each of those, what do you want to call them, sensors are at, basically. That's their frequency. This is their high range, their low range, essentially, assuming a perfect crystal that has been provided to us. Max utilization is, of course, we just set a number in there. It's 50% right now. Again, we talked about as you develop your processes, you'll find out what's an appropriate value based on where you start to see error at. It's all sort of relative to what you're depositing and things like that, what they're exposed to. So that's why we kind of leave it up to people, because we can try and provide recommended values, but it might just be tool to tool slightly different as well. Small things. But yeah, that's where you would update those. Oh, and one note again, you'll see this is 2A and 2B for 2. Again, that's just it saying it will actuate over, so you can use the full life of both.
Does it say which one? Does it say which one it's got? That it's
so inherently it will start on A,
okay,
and then it will transition to B if A is out of range.
Yeah.
Shutters, pretty straightforward. These are your 2 split substrate shutters. You manually open and close them. You can kind of hear that. You can also watch it if you open the sight glass.
No, they move.
They move.
They move.
Yeah, but if you're ever finding weird uniformities, maybe just double check that they're opening nice and evenly.
Where they should be.
Mostly that they're opening nice and evenly. Little differences in air pressure, those little knobs. If someone bumped one, for example, it could. But they do have locking nuts to put them in place, so I believe they should be right now. And if not, I'll lock them out.
Well, things jitter and move, so.
Yeah, and just also air pressures change in the building sometimes, even with the regulator on. It'll move relative to it. So, yeah. So, similarly, there are also, you can actuate each of these, but you can't really see it in this scenario. If you defeated the door, which I did when I was doing my testing.
You what?
Defeated the door, like I defeated the door lock, so that way I could check these at atmosphere that they move appropriately, but they all do. And similarly, you can force the dual shutter to open and close. That's just, again, that one that's in behind in here. Yeah. Servos page. So this one, maybe less interesting, but is useful to know. So basically, 1 second. If you know which one should be pocket one, like if this were to ever jam due to buildup on the interface of those, and it failed to rotate correctly, which again, regular maintenance and vacuuming that out, very recommended. Just around that rim and stuff like that, you'll get buildup, and that would cause it to jam so it can't rotate. It would probably catch on that lip.
Yeah.
If it ever struggles like that, torques out, whatever, you get in contact with me and stuff like that. But in short, if you like know what pocket one is, because let's say you keep that carbon at pocket 6 always, and then you just go to the one after that, that's your pocket one. And then what you would do is you then hit home, and it'll assume that that is your, like.
So if it fails to move over, it's not going to, will it not register that it failed to move over?
Oh, no, it will register that it failed to move over. It'll torque out, basically, provide a fault. It'll be a big problem. But you'll vent, you'll clean. I'm saying after you've done that sort of work and you've got it at what you know to be pocket one, like angularly, then you would just go and hit home. And it'll just say, that's great. And set that as 0, basically, like that. So this is the overrides page. You can see here, even in supervisor mode, there are things that are unavailable to us right now. And that's intentional. So on this overrides page, you'll see right now almost everything is grayed out except for the fact that it's blue because it's below the base pressure set point, which is 2x7. Or sorry, it's above that. So it's 7, either -6 right now. We're still a fair bit away. We'll go over how to change or adjust that to whatever your needs are, because that could be a significant amount of time, that could be an insignificant amount of time, depending on how low you need your base pressures to be. But I was going to say, since these are in a sequence, these are unavailable to us. But if I were to abort a sequence, I could then operate these manually to an extent. It will not let you, say, dump your turbo on this tool. Like, you know what I mean? Like, you would have to, like, it won't let you just readily destroy your turbo, because that would be a silly
nice.
thing.
That's nice.
Yeah. Now, I'm just going to show the recipe page quickly. Yeah. We're not going to do the recipes right now. Yeah. Just, this is where it is. This is new, open, save, verify, and close. Just because that's like a whole, that's what it's all about, and we will come back to it just to sort of actually go through them. Setup, so again, this is where you saw me come to. This is the setup page. It basically lets you change your set points. Put them in Torr, bar, Pascal if you have a preference. You can specify if your cryo vent gas is nitrogen or argon, your vent gas nitrogen or argon. What you think is an okay base pressure. So again, if you think 1 e to the -5 is okay, I'm hitting 1 because it's the max, so it'll go to the max.
Yeah, this is just the
these are just defined. Yeah. You can always just hit load defaults and go back to them. So you'll see right now, like if I just wanted to be able to start a recipe right now, you would update that. But know that you may impact other people, so set it back or things like that. Okay, for deposition pressure, more or less the same as this. It won't really change anything. Crossover pressure, like we discussed, safety pressure is related to some safety interlocks that exist. It's not necessarily like what you might think it's for. Atmospheric pressure is just loosely defined at 700 torr, just so it knows when it sees that value, anything above that is over range, basically, which just means it's above what the range, the pressure gauge can measure. Cryo pump, crossover, this is more for pump and purge, same idea for the regen. Pump and purge, again, these are where these two values are defined I was talking about, where it'll vent to a certain one and then pump it away, vent to a certain one, pump it away. So it goes to 100 torr, then roughs it down to 1 e to -1 torr. It'll do that a few times based on, again, if you're just trying to make sure that there's no debris or toxic materials, whatever people are doing. These are your cryo set points as well. So the low temperature, this is used during the regen. So once it hits 20, it assumes that it successfully regenerated. If you're running a process, or as you run processes over time, it of course will build up contaminants. So once it goes to 50 mid-recipe or something like that, it might fault and say, hey, like something's up with your cryo, basically. that point, you're probably regenerating, or you're going to look at doing maintenance, things like that. Again, we do have an entire maintenance guide also within this manual. It's more generic, so it is sort of case by case for like weird tools, but I'd say almost anything on these two tools should be reasonably covered in here. There's a little bit of overkill, in my opinion, but it'll be things like weekly, check for abnormal vibration and noise from your pump. Things like shield removal is as required, blah, blah, blah. It has everything in here that will also cover like every 6 months, like regenerate your cryo. If you're using oxygen, do it more frequently, which would be the case maybe on this one. But since it's a dual pump, it should actually close the cryo pump when you go to flow gas. So that way it's just the turbo that it modulates the pressure with. So that way your cryo gets more longevity. So that way 6 months is more appropriate.
Okay.
Yeah, things like that. Again, it's all in here for like general maintenance. So if someone has a maintenance question, you can even just, PDF, print those few pages of it. If you need it set aside in a binder, whatever works for people, basically. But it is just here on the desktop in the manuals folder. Yeah. Then we have our materials page. So remember when we were loading our materials, that long, long list.
This is where you make the new ones?
Yeah. And if you want to adjust an old one for any particular reason, you can still do so. So barium nitride, you can see the density, the Z factor, and what max temperature you'd like people to use it at, and all that sort of stuff. The density, straightforward. You can find that anywhere. The Z factor is basically how well this crystal will respond to seeing deposition from it as like a unitless ratio. So basically, there are normal ways of doing calculation of how much change in frequency results into how much material has been added. And there's sort of like a straightforward number for that. However, different materials sometimes have a different Z factor that will affect this. These are things you can find in literature.
Okay.
You do not necessarily need these, I will say, because if it's something that you're not using all the time, if it's something you really care about even, there's also a tooling factor that will be used in recipes. And inherently, if you're always going to be depositing about the same thickness of material, it will also be accounting for your Z factor just by doing a couple tooling factor runs. It'll make a little more sense in a bit, basically, but the tooling factor is essentially like an efficiency rating. So like, let's say you are depositing. Now since your sensor is lower than your stage, where you're actually putting your material, let's say at a 2-to-1 ratio, you're roughly like on your straight beam path, if you're treating it like a point source. If this was roughly double to your material, then your efficiency would be about 50%. But let's say your Z factor was something like 1.2, you might have a much lower or a much higher, I think it'd be a much lower actually observed value up here. So if you threw down 100 angstrom and based on your sensor, you would only see, say, 30 up at the actual source.
Okay.
Or on your substrate. Again, it can kind of encompass it for you, so you can always just leave it at 1 if you're not sure. Typically speaking, not something you have to worry about, though. There's a lot of materials in here.
What is a linked material?
We'll cover that on the sputter tool.
Okay.
So that's just for reactive sputtering needs.
Okay.
Yeah. But if you are working with a material, an alloy, something that you don't typically, that doesn't exist in here, you just hit create new, provide the name, density, Z factor if you have it. Again, if not, leave it at 1. Then you would just save it. That's it. And then you'll be able to pull it into your recipes. User management is where I was talking about, where you can control your features and things like that. So again, you'll see here your tabs and each sub-tab. So if there's a particular function on your, say, in the system, you want overrides on this to be available to the operator for the beacon.
Okay.
You want them to be able to change the beacon color, because why not? It's now available to them if you click that little checkbox. Pretty straightforward. There's more details on this in the manual on how to go about setting up new user or user levels and stuff like that. If you have an interest in that. Tooling factors. So So this is what I was referring to. So the concept of sort of an efficiency ratio for how well it deposits. Again, you'll see different numbers for different things, especially because things like your sensor, this one's much taller, so it's closer to an observable value of what your substrate is, and it's on a diagonal, so it's technically taking a slightly longer distance to be able to get there. Also noting that with EBeam, pitting is a common issue, so I like to use like circular sweeps for that reason to try and avoid it as much as you can. It's so inherently going to build up heat in the middle. So you will essentially still have a reasonable point source, but at least by evenly heating it in a circle, get a little bit more rate control and stability. But with certain materials, you'll need more power to do that, which takes the lifetime away from your emitter. There's just sort of like trade-offs for everything, of course. That being said, yeah, these are just some of the ones that I predefined. So an SB38 boat that had aluminum in it was 30 or 31 basically. Yeah, silver, S38B. You can also do things like add user options, so you can just make new things like the thickness, for example. I think it's a very common one. You can just change it as like thickness. So that way, you may imagine that when you go to, yeah, we'll do it large, why not? You may imagine that if you're depositing only 200 angstroms versus 20,000 angstroms, you're going to need wildly different like tooling factors, just because, yes, it does a reasonably good job of measuring it, but maybe over a longer run, there's just small error buildup, so then you're only getting 19,000 instead of 20,000, for example. So you may find it may be useful to have two resistive aluminum ones with an FE boat, and then you would just designate the thickness, and then you would save it out that way. So that way, when you're building your recipe, you can select multiple tooling factors for the same sort of setup. Concept overall being that you have more customizability, as long as you just keep it in a relatively ordered fashion. You can even put just your name or something in the description or things like that, just so you know it's your tooling factor that you worked with. A lot of things like that people will do just to sort of keep things more orderly. Otherwise, it can be easy to pull in the wrong tooling factor, and then you're getting a wonky result versus a previous result, and you're not quite sure why. Knowing that sometimes these tooling factors are shared between recipes. So that's why you have to sort of be careful with that. Rate control, similar to the tooling factors, the EBeams you can see here have a variety of like rate control profiles, a PID profile for auto tuning for rate. This is again recipe to recipe, sweeps will change. And these will sort of change run to run maybe, but if you have one that you really like, you can set it aside and or borrow from a previous one if you're not quite sure where to start, things like that. These are just sort of ways of ensuring that the PID response of like how it'll modulate power to control a rate will respond appropriately. We'll go through that again when we actually build our recipe for chromium and stuff. It'll make a little bit more sense. Licensing you don't have to worry about. It's already fully open. Data viewer. So every time you run a recipe on here, it logs like a log of that run. So you don't have to worry about that. It's only if you run things manually that you'll use the real-time data viewer, which I'll go over in a second. So you can see these where it's like 80 test logs. These are some of the ones we ran. Here's one I ran of silver. And it's just a little CSV file. You see like the power set point that it was using. Those are just set points as opposed to, what am I looking for? So there's prefixes and suffixes, so sometimes it might be worthwhile to change it. So I don't really care about the resistance. So now I can only see the ones for that. So you can see like the actual rate, right? Like how it was moving with it. I probably aimed for around 2. I was hit 1.9 pretty accurately there. 0.99. Doing a pretty good job there. Great. The actual thickness, you'll see it go up. So this is probably my deposit step. Because it's like, yeah, it accumulates and then it basically re-zeros itself with the deposit step. So that way it knows when to kind of stop. I was probably aiming for, yeah, 150 angstroms, I guess. Cool. And then it stopped. and that's when it closes shutters, etc. So that's what like a run would look like. Now this is our real-time data viewer. This is if you're ever recording something live. A good example of this is your pump downs. So that's not done in a recipe necessarily, because a recipe is like you're depositing something is typically the goal here. So this is like if you just wanted to watch the pressure as a function of time, you can just hit that, and it'll do that. You can tell it to be logarithmic or numeric. You can tell it, you can probe it to see, watch it, see how our pressure is going down. You can pan and zoom, just if you want to observe it. It samples at half a millisecond. You can also hit fit to live trace. It'll then reopen it. Tell it. Now, if you actually wanted to record this information, though, so this is just me monitoring it right now. I'm not actually doing anything with it. If I actually want to record it, you then need to specify your sampling time and time of recording first, so it can pre-allocate for it. So you'd say like 200 hours, let's say, max is 240, and then do 10 seconds or something like that. And then you'd say start recording, and you can see this was my first regen and pump down, is what it looked like. You can sometimes just put PD or something like that, in my experience, because PD is pump down, then do a little underscore. And the reason for that is it will automatically like do that date, that start date.
Nice. Okay,
yeah, so that way when I can go to the data viewer and look at it. You might say, well, that's the logs folder. I didn't see any real-time data viewers. Just up above the logs folder, you get a real-time data trace, and you'll see it.
Nice.
If I were to open it now cannot write and read at the same time, so you would break the log. Like you won't break it. You'll open it, what it's recorded so far, which is essentially nothing. So be aware to not open any running logs, basically. But if you wanted to look at this one from this previous pump down, you'll see I have the pressures and temperatures.
Just curious.
Yeah, so like you'll see the temperature slowly coming down, and then our base pressure starts coming down. These were just initial pump downs and stuff just to see how it's coming. It's doing well, so I was like, oh yeah, awesome. And then the next day we stopped it. But yeah, so that being said, if I were to stop this one, you can preset configurations if you like certain variables to be in there. So I did that for you with this. However, this should be logarithmic. I'll save that. But yeah, so if you are logging certain things repeatedly, you can just build the configuration, save it, and then you can always just clear it if someone's got a bunch of stuff open you don't care about, and then just go find the one variable you care about or whatever, instead of having to close them all individually. The alarms page, everyone's favorite page. So if you have an issue, it would be popping up here, and you would have to acknowledge it. Examples of this are from our system history, things like I was disabling those. The sensor is in error from when we popped it out. There is failed to reach cryo low temperature set point. This was something unrelated basically. During setup, one of the lines were crossed, and then away we went. Resistive, no current flow detected. MCR not on. That was because the E button was E-stop button was depressed when it first showed up. Air pressure is not okay. That one is what we experienced yesterday, basically, of our air pressure is too low. What do we do about this? And that's what led me to go check the PSI, and then, oh, building struggling. And you can see that it keeps a history about as long as it was running. So if there's a big power outage, you might not have these available to you other than the ones it'll have on startup. On this tool, to build a recipe, you would obviously just go start with new. Once you have a recipe built and you like recipes in general, you can of course, or this is more modular that you can steal off old recipes and just like alter them. I'll show you what I mean by this very quickly of like, I can take this aluminum one, it's 2 angstroms per second. Let's say I really trust the stabilizing. I don't need to auto-tune, nothing. And all I want to do is I want to move it to even just the resistive one. You know, I want to do that. There you go.
Save it as a different one.
Yeah, and then I might have to change the things here. I don't think you actually have to, but when you go to hit verify, it will give you an error.
What do you mean you wouldn't have to? Would it just automatically do that?
So when I go to hit verify, okay, so the rate control one won't be happy, so you'd have to change this one.
Yeah.
But this one has a warning saying, hey, you're using a tooling factor that's defined for a different source. You can use it, but it's just letting you know that that doesn't really make sense, basically. Like, why not just either make a new one or something like that? Now, again, the idea being that I don't have to rebuild this whole structure, and all I did was I changed one thing here.
Mm-hmm.
And you can copy and paste these things to like remake them and make multi-stacks of them, things like that. So I've just tripled the same thing 3 times in a row. Not really sure why you'd want to do specifically that, but let's say you wanted to. It's easier than starting from scratch every time and adding a new material every single time. You'll see what I mean, because we're going to do it that way first, because that's what we got to do. You got to see it fully come through. So brand new recipe here. You'll see it drops us on sources. We'll add a source. It'll say S1 for source 1, or sometimes I'll put E1 for EBeam Pocket 1, stuff like that. It's just sort of like nomenclature, so you can kind of know which one you've built into the recipe. This will be good for the naming of the recipe. So that's why when you were saying, like, how do you know how does it choose? It doesn't. You define it, basically. And so this is where you define it. This is your list of sources. It's either resistive 1, resistive 2, etc. And if you're not sure which, again, you can either go to the load material page for the EBeam pockets. Same with the resistive, but you can kind of also go to our source page here. 1, 2, that's your EBeam. And then your pockets are all listed. So if you were looking for a particular material, and we loaded EBeam 2, and we didn't actually write anything, so we should have.
Yeah.
So our load material, and we want to tell it that chromium is in it. Here. So we're building one for chromium. You know it's on pocket 2 now. Pick pocket 2. Sweep select. There are 8 different patterns that you can build into this. You can see right now it's just a single dot in the middle. That is for pattern 1. Got a pattern. Oh wait, it needs remote off. So you basically remote mode is remote control mode, which means handing it over to the computer to fully operate it.
Yeah.
So you want to take it out of that mode because you want to change what the pocket is. So that's our second pattern. It says there.
Okay.
That's one I had. There's 3, which is like a sine wave one. There's all kinds of funny ones. You have 8 different options you can program into this. Of course, we haven't run this material before, so we don't have a rate control profile for it. We could borrow another one, but we'll just start from scratch. So this little plus button to build a rate control profile. Now, maximum power, it gets hard to pick this number immediately because you don't know what's a real safe amount for it yet. So you can pick a low number, you can pick a higher number, and then basically when we go to run this recipe, I'll show you what I mean. You can kind of find out what that number is and then change that. Change the maximum power mid-recipe, save it all over after. So that way, it'll be like you kind of go stepwise up of like you start out, say, 1% power, and just kind of coast your way up to find when do I start seeing rate close to what I'm expecting for rate. And then you would just then go give it a little bit more than that and say that's your maximum power. Okay. It already has a lot of power available to it.
Should we start at 1 then?
Oh, no.
Okay,
We'll start at like 20, which is probably way too high. I do the other way where I give it too much work in the recipe to find out what that number is, and then I'll change it. So I don't know, how quick of a rate do we typically want for chromium? Probably like 2 angstroms a second or something, because you only want 50 angstroms or something, I guess? Yeah? So 5 as a max rate is, if it exceeds this number, it'll stop the recipe just so you don't like, especially with something like chromium where it sublimates, it'll just like, start shooting out of the pocket because it's too hot now. So you don't want that. So 5 angstroms a second, completely fine. And then we'll pick that rate control profile we've just made. And then from there, we'll go and create tooling factors. Now, before I hit plus and build the tooling factor, I'm going to cheat a little because I've already done the work for this. And I know that. I ran silicon dioxide. We just made this one up. So discard changes, yes. Silicon dioxide was about 98 apparently. So we're going to use that. So chromium recipe. Tooling factor, we'll give it a number of 98. And we'll go
Pass it.
Now you can add a description. We could put like adhesion layer or something like that, just so we know. I'm gonna put demo just so you guys have something to look back to. Now you'll see it already picked what sensors are going to be looking at it, so you don't have to worry about that. And I'll be using it for rate control, thickness control. Now you see I have to remake it again, just because sometimes people are particular to the point where they really care that A versus B, that slight change in geometry, has a different tooling factor. Again, just depends how particular people get. So I'll add a description to that after. So that's it. That's our source. That's what we'll be depositing. Pretty straightforward. Startup is pretty much always the same. You are basically always pumping down your chamber and rotating. Why 10 RPM? That just like you just want it moving, bare minimum moving. You can go faster, but it's not necessarily needed unless you're doing short depositions, like really short depositions where it's like this opens, it's exposed for like 10 seconds and closes, because then it matters how many times around.
So that is actually evenly?
Yeah, but typically speaking, you're open for more than 10 seconds. But even in this recipe, we're going to be doing 50 angstroms, and we're going to do 2 angstroms a second. 20-something seconds is probably enough to kind of see a full rotation or two. But if we want, we can increase it just to see it moving. Why not? Now we're on the process. So that's our startup. Not everything's available in the startup, basically. So everything's available in the process. There's 2 types of things here. There's empty, co-deposition, and deposition. These profiles are pretty generic of like standard stacks of what you'll probably be wanting to do. But up to you kind of which you use. Like I build them from empty typically, but for this tool, this will actually be really useful because these will basically suit your needs perfectly. On the sputter tool, you'll see it's not going to be the case. You're going to want to almost start from scratch or build off an old one is usually easier. Just because there's going to be little things that are not mentioned or built up. So I'm just providing a name to the layer so that way it's clear to me what we're doing with it. So in this case, we're not really sure how much power we need, and that's output per second, so you'll probably want that per minute. We'll give it like 5 per minute, and then we'll give it, what we're going to do is we're going to give it a reasonably large soak time so that we can kind of play with this number and find out what it needs to be. Soak time is the concept of once you achieve your target, then you hold it for that period of time. Since we're going to be adjusting that value live 300 tons of time. Then what we'll do is, as we live edit and change these things, we'll put it to a more finalized state just afterwards. So once we kind of find out what it takes to get 2 angstroms a second of chromium, we'll stabilize at 2 angstroms a second of chromium. Accuracy threshold, like you could even go 20%, and that's like not very much range. Like that's only 0.4 angstroms a second of movement, which is very little, plus minus. Hold time 30 seconds, let's say, and we'll give it a timeout to achieve this of 3 minutes. Then we'll go to deposit. Again, we'll give it a target rate to be depositing with, target thickness, and then it'll auto-calculate a timeout for how long that should take. It'll be 25 seconds plus or minus this or that. Sure. 0 the thickness at start. Of course, the only time you would say no to this is if you're running gold or something very expensive and you just want to be depositing the whole time. You don't care as much about uniformity because it costs so much. You could take the shutters out essentially, or leave the shutters open at every step, and then just not 0 at the start, so that way it's like accumulated, and then it'll just go until it sees that thickness and end. because you'll see here substrate shutters are open on our deposit step, but our stabilized step, our precondition, of course not. We don't want to be depositing it. And shutter open, sensor open, etc. Same idea. We're going to go back to 0. Output per minute of 5. We'll find out what's a more reasonable time. And you don't need a soak time for it to be at 0, because an implied thing is at the end of this recipe is that it will kind of go back to neutral state. Again, just sort of pump down. It's not running anything. It'll turn off its sources, etc. So you don't have to be concerned about that, having to be sure that that's the case. The only reason why you want to do it a ramp down typically is so you don't just hard cut it and then crack your crucible due to heat exchange difference there with the liner. You don't want to keep cracking your liners over and over again. It's expensive or just costly for no reason. More or less, that's a basic recipe. Now, we've told it to stabilize. It has no real PIDs to be stabilizing around though. It hasn't done an auto tune to be able to determine an appropriate PID value, set of values. So what we're going to do on this recipe.
Sorry, what PID again?
So there's a PID feedback loop of rate versus power that it will do. But it needs to do that basically. So we need to give it an auto tune phase. So you just right click, insert phase above or below.
Okay.
Same idea if you go to this and you say insert layer above or below. We'll do an auto tune action of, we're aiming for 2 angstroms a second. Give it a timeout of 2 minutes, sure. Very good. We'll hit verify. Now, you'll see something with the naming setups that I've done, like E2 is EBeam Pocket 2, S1, Source 2. You don't have to stick to these, but it helps when you go to then select it to know that you've picked all the correct things. So like you'll say the right material, the right pocket, so that it all aligns, so that when you go to actually run your recipe, it doesn't just spit out in there and say this is built for this pocket or this is built for this resistive. So in this case, we are pulling from EBeam Pocket 2, so E2, CR, and then 50A, and and one thing I like to use is at the end of a recipe or something like that, if it has an auto tune in it, because you don't need it, you can either write the word auto tune or AT. Okay. So we're going to save this E2 chromium 50 angstroms, 2 angstroms per second with an auto tune. Now I'm going to load this one. I go here, browse, load, E2, chromium, all that good stuff. I'm not going to end up doing the deposition of this. I will just show you that it will stabilize and things like that, and how it does that. The reason being is because we're going to build a recipe that will then do this and then that silver sort of back to back, just so that it saves us, trying to do this in 2 parts, which you still can because it's under vacuum, like reasonably, but just cleaner to have both in one recipe. But the concept I was going to show is that you can copy and paste from one recipe into another for those like back-to-back layers, which, I mean, it's not perfect, but it is still way faster than rebuilding it all. So we're going to hit start. It is now going to start depositing, or start warming up. It's not even 2%.
Is there anything to actually look at? Right?
Yeah, so you can see that it'll probably be doing something like this beam sweep, but I'm going to take a peek. Okay, so you can kind of see it. It's still like dull.
Yeah, you can see it rotating.
Yeah.
Get out of your way so you can take a look at it.
Now, I'm going to slowly crank it up to, say, 4%. And again, it's not doing it very quickly. I'm also just going to keep an eye on rate at the same time, but you can also watch it to make sure it's not like wandering off. Yeah, you can kind of see it's already getting one hot. You can see we're starting to get some rate here, just at 4%, which is already
glowing.
Yeah. So, starting to level off actually right around 2 angstroms a second. If it's really bright, you can do this.
No, it's very white. That's the color of it.
Yeah, you can barely make that out, but yeah.
Oh no, yeah, you don't need that.
Yeah. Well, not quite. It's
I don't
getting
think
there.
so.
It's getting there. As it goes to warm up. So you can see here, 4%. We're already at 2.3 angstroms a second. Based on our tooling factor, again, maybe isn't perfect. Tooling factor runs are very important. Again, concept being that you just, so you can see here though, like if you were building a recipe, this is already too high. So you would want to be at maybe 3.5, just because you want to come in a little under your target rate. And then the auto tune will basically PID by doing the old give it 100%, watch until it achieves target, and then give it 0%, watch how it comes and responds and hits target again, and then do that like twice basically, and then build a PID profile based on that. So in that case, we may even come in lower. And again, things like EBeam where it's thermally related, it's always exponential moves, so you got to be careful and sort of, because I was trying to be gentle by going, 2 to 4, but clearly I was wrong, so moves quick, you know. So this is what I mean by you just kind of go like 1 or 2% at a time, but if it's something like a metal that it always comes back to thermal conductivity, so aluminum will dissipate the heat perfectly. So you can just move it pretty fast, like 5% at a time, no problem, and it'll slowly eventually evaporate, right? Whereas things like chromium, which will just sort of sublimate at any given so yeah, it'll stabilize this rate using this profile. If we're really happy with it, then basically we're good here because I'll do the deposition. I'll do this again using these updated values.
Yeah.
So I'm going to stop the recipe. A little hard on the crucible, but it's only like 3%. I think it'll handle it just fine. If you cancel a recipe, of course, something's wrong because I've told you something's wrong. So that's the alarm is basically going to say. Yeah, I can acknowledge it up here or here. Goes away. So that we're all good. This is reasonable. We like all these numbers. This is great. What we now want to do is we've made alterations to this recipe. So this is the loaded one, and this is the current one because we made adjustments to this. This little yellow symbol tells us this.
Yeah.
We will save this as ET chromium. Yeah, we'll override it basically. Like, do you want to replace it? Yes. Do you want to save the current PID values? That way the default ones won't be
the current ones are the ones that, yeah.
We just made, yeah, correct. We say yes. Say load the saved recipe. We can say yeah. Just to look at it, make sure that it actually updated appropriately, and yeah, look at that. It's using the correct values now. We're happy. So this is all good. So now we're going to build onto this so we can have a multi-layer recipe. So we're going to add a source, of course. We're going to add our source of our silver, which I think we had on resistive 2. Clockwise ends up being the way we go. So we'll pick our material here. It'll be our silver. Wonderful. Pick all our profiles that already exist. It says what kind of boat we used, because I put that in just as like a point of reference in case somebody used a flash evaporator instead or anything like that. Rid of auto tune. Both are going to run at 2 angstroms a second, so I'm going to keep that the same. We'll call that S2. Oh, man, I got klutzy hands today. S2 and AG. I know with that, we typically want films thicker than about 2,000 angstroms thick, if I'm not mistaken. So I've renamed this, and I'm happy, but we only have the chromium layer. Now we can go to this. Go to this recipe. Steal this. So we can go here now. This is that layer. Obviously, it's only depositing 150 angstroms, but whatever. We'll assume that we're reasonably close. Go to this recipe we built. Go to Open. Click on the process. Right-click. Oh, sorry. Yeah, right-click and paste. And just like that, we have. It's going to ask for the source, so you have to just tell it to use this one. But pretty straightforward. Or no, we want 2,000. Cool. And that's our recipe. you can see what I mean by borrowing just gets kind of easy to do. That should work. It should be easy. Yeah, so we're happy with this recipe. We're going to go with it. Go to main. We're going to go here. Open our recipe that we just built. Load. And then we're going to hit run. There we go. And now this with our updated. Oh, I see. So yeah, that should just run now. Now it's going to try and stabilize from 1 angstrom up to 2. All right, and now we're depositing. So yeah, we already finished our EBeam. Oh, sorry.
But
It's just starting to do the silver ramping up now.
did you change something or?
This recipe should work the silver, so it should be good. It's because it's thermal, it's a little slow to respond.
Yeah.
That's fair. It's going to start cranking power to get an actual rate. That's fine.
This is rate for
Deviation.
deviation.
Because it was getting 0, yeah. See?
Yeah, now it's doing something. It's finally doing something.
Yeah, thermal, right? So it builds up power, heat. Then you can't really dissipate it quickly, so it's coming.
Yeah, you can tell. You can tell it's glowing over in the corner there.
Yeah. Whereas, yeah, this probably should have a come-in rate of closer to like, oh, that's like 25, and it's like maintaining. Maybe this needs only be like 28 or something. So the next run, it'll be a little more cleaner on that.
Yeah, it was a little wonky.
Because you want to start the seed deposition rate, but not have it sitting there for forever. Basically, you want to see like a quarter of your target rate and then let it go to stabilize, because then it'll actually bring it nicely. These are all just sort of hand wavy numbers anyhow. It's just roughly that. But you can see it's still going to achieve a nice steady rate.
I see what you mean by like it went.
Yeah, it's just controlling it more appropriately. And we're doing plus or minus 10% on this, so this is a nice steady rate. You can also see accumulated thickness through the run by clicking this little drop down. And so we've already deposited 500 angstroms. Pretty solid. Doesn't seem to be struggling too much. So neat. Sensor 1. Crystal air. No.
Crystal air. What's that?
Means it's got a bad feedback for some reason. My guess is it had something else on it, and so when we were depositing all this silver, it then got confused, I guess. We'll troubleshoot this when we vent. In the meantime, we're going to vent. I don't think this will come out to anything we can maybe measure with the flow film, but I just hit stop on that recipe. And we're going to acknowledge it because I stopped it. And again, we're going to take a look at this, see what's up with it. And then we'll...
crystal air?
Yeah, we'll replace it. Probably 2-year-old crystal that got a bunch of stuff previously on it, maybe aluminum, maybe silver. We'll see here. All right. There you go.
Looks good. It's definitely got chromium on there.
Definitely got silver on it. Also, an old crystal that already had deposition on it from my testing 2 years ago or whatever it was. So it could just be that we need a new crystal. I want to confirm if it's gonna like complete the next time, basically. That way, I'm not leaving you with a not working recipe.
Yeah, don't leave on